You know that sound, right? That sudden, ear-splitting shriek that just stops everything cold. It's a sound that's designed to cut through any noise, any distraction, and for a really good reason. But have you ever actually stopped to think about what's happening behind the scenes in that moment? How does one tiny wisp of smoke trigger such a massive, life-saving response? Okay, let's get into it.
All right, so here's what we're going to cover. We're going to trace that whole journey. We'll start with the system as a whole, then get into how it actually senses danger, how its brain makes a decision, how it sounds the alarm, and finally, what keeps the whole thing reliable and ready to go. So first things first, we got to stop thinking of a fire alarm as just that red box on the wall. It's not. It's actually this whole complex, interconnected network, and its one and only job to give us the earliest possible warning so we can all get out safely. That's it. At its core, the whole thing works on a super simple but lightning-fast three-step domino effect. First, something has to detect a fire. Second, that signal gets sent somewhere to be processed. And third, once the danger is confirmed, the system has to notify everyone. Detection, processing, notification. That's the sequence that saves lives every single time. Okay, so let's look at that first domino. Sensing the danger. This is where the system's nerves come into play. We're talking about all the little devices scattered around a building that are basically its eyes and nose, just constantly on the lookout for trouble. Now, the official term for these things is an initiating device. And it's exactly what it sounds like. It's any part of the system that can initiate the alarm sequence. It's the very first link in the chain, the one that screams, "Hey, something is very wrong over here."
And these devices, they really fall into two main camps. On one side, you've got the automatic ones, the smoke and heat detectors that are always on, just silently monitoring the air for us. But on the other side, you've got the manual devices, like the classic pull station. These rely on the single best fire detector ever invented, you, a human being. If you see a fire, you become part of the system the moment you pull that handle. Okay, so a detector has spotted smoke or somebody's pulled a handle. A signal goes out, but where does it go? Well, it goes straight to the system's brain. This is the central command hub that takes in all that information and decides in an instant what to do next.
And this brain, it's called the Fire Alarm Control Panel, or FACP for short. Just think of it like mission control for the whole building. It's basically a special purpose computer that receives every single signal and has all the power to act on it. Seriously, without the FACP, you just have a bunch of lonely sensors with no way to talk to anyone. And look at all the things this brain does in a split second. It gets the signal, figures out exactly where the problem is, and then boom, it activates all the horns and strobes to get everyone moving. At the same time, it can be automatically calling the fire department and is constantly checking itself to make sure every little part is working. It's the multitasking, unsung hero of this whole operation, for sure. All right, the brain has made its decision. Now it's time to tell everybody. And this is the part of the system we are all most familiar with, that loud, impossible-to-ignore voice that just shouts, "Danger!" The technical term for these things is notification appliances, and their job is to use sound, light, or maybe even spoken messages to make absolutely sure every single person in the building knows about the emergency. You've definitely seen and heard these. You got your horns, which blast an alert at over 100 decibels. To give you some perspective, that is louder than a power saw. Then you have the strobes, those super bright flashing lights. They flash at a really precise rate, one flash per second, because they're designed to be unmissable and cut through smoke, which is absolutely essential for alerting anyone who's hearing impaired. And in a lot of newer buildings, you'll also find speakers that give you clear spoken instructions. So we've followed the signal all the way from the spark to the siren. But a system is more than just its individual parts, right? It's about how they're all put together and, maybe most importantly, how they're maintained. This last part, it's completely non-negotiable. So broadly speaking, there are two main ways these systems are built. Older systems are often conventional. They work in zones. So if an alarm goes off, the panel might just say, "Alarm in zone 2," and that could be the whole second floor. But modern systems are addressable. In these, every single detector has its own unique digital address. So the panel doesn't just say Zone 2, it says Smoke Detector in Office 214. That difference gives first responders the exact coordinates of the danger, which can save minutes that absolutely save lives. So how do we make sure all these systems, no matter which type, are installed and maintained the right way?
Well, that's where this comes in. NFPA 72. It's the National Fire Alarm and Signaling Code, and it is pretty much the Bible for fire alarm systems. It tells you everything from how loud a horn has to be to how often a system needs to be inspected. And this really gets to the heart of it. You can have the most advanced, most expensive system in the world, but if it's not tested and maintained by the book, by standards like NFPA 72, it's just a pricey decoration on the wall. Reliability only comes from being diligent.
So we'll leave you with this final thought. We've taken apart the technology, from the sensor to the FASC to the siren, but the system is never truly complete without its most important component, and that's you. Being aware of your surroundings, knowing what to do, that's the final piece of the puzzle. So seriously, take a look around right now. Do you know where you'd need to go to become part of the system if you had to?